Well, welcome everybody to the Maryland Energy Innovation Accelerator, our 2003 pitch finale. This is when we get to celebrate the graduation of 4 companies as they have completed their second deliverable for MEIA. We can go ahead and advance the slides. Here is the list of the companies that will be participating: Alchemity, Living Canopies, Ionic Devices, and Brightwave. At the end, we will be able to get some email addresses so that you can reach out for more information. But again, this is a celebration for us today here at MEIA, and we're just glad that everybody can join. Next slide, please. Next one. So I'm Wade Harley. I am the director here at MEIA, and MEIA is the brainchild of Ben Margolis and Brian Toll. And the main thing to know about MEIA and the idea that they had and pursued and perfected is the energy executives in residence. And the goal is to work with professors at our Tier 1 universities here in the state of Maryland, UMBC, University of Maryland, College Park, and Johns Hopkins, plus the other universities and federal labs, to find the IP, the intellectual property that has been developed, help those professors build executive teams, and move that technology into the marketplace. That is the idea, and that is the idea that seems to be working, and quite frankly, the idea that should be replicated in other places. From there, they expanded the idea to bring in some professional support services, strategic partnerships, and we'll be talking about those partners in the MEIA program later on. And then the MEIA staff, what we really work on is program management. Next slide, please. So we really have 3 programs here at MEIA. Pre-Accelerator, which Mike Ducker is actually actively working on as we speak. It's during the concept phase. It is pre-prototype, working on the ideas, and we put together an executive in residence and help the team or the idea reach out to see if there's a market for the idea. As they move forward, we move them to the Launchpad program. That's for a company that now has a prototype. The prototype's ready to go out of the lab. IP may have been filed, but we don't have a legal entity, and we need to build a management team. And so that's where we work. So at the end, so we recruit energy executives in residence. We work on a business model canvas, and we finally work on a pitch deck. And that's where we are today. The teams that are completing the Launchpad program and are making an official pitch. And then our final program is the Accelerator program. We probably have a legal entity. We have a management team in place, but we bring in energy executives in residence to augment the team and solve a specific problem. Next slide, please. Next slide, please. I don't know, it may have frozen.
Yeah, it just froze.
So the next slide is going to be it's kind of a mark your calendar. On October 16th, our friends at MTech are working with us to do a MEIA Climate Tech Day. It's going to be on the 16th. It's going to be at the College Park Marriott Hotel and Conference Center. Earlier in the day, the MEII board will be meeting, but at this event, we're still working on it, but MTech is working with us. We are going to have every MEIA team that we can have to at least have an easel board presentation on where they are with their products, and MTech and MEIA companies that are ready to do a pitch will be presenting at that time. And it is the day before the Maryland Clean Energy Center's climate salute, or it's I got the name of it, the Climate Solutions convention, which is going to be on October 16th at the same location. So please mark that on your calendars. You'll be getting more information, but we hope you will be involved in it's a clean energy summit. We hope that you will be involved with both opportunities. Next slide, please. And with our welcoming remarks, I'd like to welcome the Maryland Clean Energy Center, also known as MCEC, our board chair and our leader, Jeff Oxnam, who is also the CEO of American Microgrid Solutions and is a proud Eastern Shore resident. But Jeff, take it away.
Thanks, Wade. Appreciate it. This is one of the most exciting days of the year for the Maryland Clean Energy Center. And I want to apologize to everybody for all the alphabet soup, starting with M's. We all have to get used to it. But Maryland Clean Energy Center, our job is to advance clean energy throughout the state of Maryland. And we do that in a number of ways, providing finance, providing education, connecting businesses and others in the community. But one of the most important, exciting things we do at Maryland Clean Energy Center is the MEIA program and this accelerator. I love being part of this day every year to watch and listen to these companies that are graduating from the program talk about what they not only have done, but they're about to go ahead and do. So congratulations to all of you for reaching this stage and for the journey that's ahead of you. Maryland is a national leader in clean energy technology, and you really represent sort of the best of what we're all about and where we need to go. As we celebrate today, we have 4 companies that you're going to hear from, and they really bring a depth of experience and impact. One is a recipient of the National Game Changer Award for reducing methane emissions. Another's developed an elegant solution for urban transit. The third is disrupting the world of algae growth. And finally, our 4th company is breaking through with developing solid state batteries. What Maryland has to offer the rest of the country is incredible in the space of clean and advanced energy. I congratulate all of you and look forward to your continued leadership and success as we move forward. Thanks, Wade.
Thank you, Jeff. Next, I'd like to introduce Patrick Wynn, and he is with the Maryland Department of Commerce, and he is my former boss, but he's also a very good friend, and he's a part-time Eastern Shore resident who is working hard to become a full-time Eastern Shore resident. So, Patrick,
and a Salisbury State College graduate from 40 years ago. So yeah, I do love the shore. Wade, thank you so much. The Maryland Department of Commerce is pleased to be the event sponsor for today's MEIA's 2023 Climate Tech Pitch Finale. Commerce is the primary economic development driver for the state regarding industry attraction and expansion. I oversee the Office of Strategic Industries and Entrepreneurship, and within our industry, we provide internally to the rest of the commerce team subject matter expertise, as well as we are the commerce facing for the strategic industries, and they include energy, agribusiness, cybersecurity, aerospace, the life sciences, entrepreneurship, and also working with higher education to help develop workforce to have a robust and sustainable position in these strategic industries. So on behalf of Secretary Kevin Anderson and Commerce Assistant Secretary for Business Development, Heather Graham, congratulations and the best of luck to all of today's participants. Thank you, Wade.
thank you. And we'll move real fast. I'll just let you know who the judges are today. We'll wait for the next screen. So we have Michael Campus with Energy Impact Partners, Brett Clark with Volo Earth, Andrew Golick with, I think it's HAX or HAX, but I think it's HAX, and then Michael Ravenscroft with the Maryland Momentum Fund. And with that, I think that concludes the preludes. And so let's get right to it and let's do this. First up, our leadoff hitter. Please welcome Dr. Eric Waxman and Roger McCain with Alchemity. Take it away.
Thank you. Roger, go ahead.
Okay, let's go. Good afternoon. I'm Roger McCain, CEO of Alchemity. I'm excited to be part of the Alchemity team because I actually honestly believe that Alchemity has breakthrough platform technology that applies to one-step electric generation and one-step liquid petroleum production as well. This platform technology can greatly enhance the way we power and feed the world, while at the same time eliminating greenhouse gases responsible for global warming. Because of the near-term market opportunities, we are focusing today on petroleum production, keeping in mind that the same platform is being developed for very high performance electric power generation. Next slide, please. Let's go to the next. The first problem to be addressed is natural gas flaring from remote well sites. As you can see from this map, which is a composite of actual satellite photos of flaring, flaring is a global issue. Flaring not only produces enormous amounts of carbon dioxide, but also unburned methane, which is 80 times more potent. This has been recognized by the Biden administration and the US EPA, and is dramatically tightening regulatory rules for methane emissions. Flaring occurs because remote sites have no alternative for removing natural gas from oil production. They have no means of transporting natural gas and lack the scale for economically viable on-site gas to liquids or gas to chemicals facilities. Virtually all stakeholders, industry, investors, and policymakers are desperately searching for an economic and practical deployable solution to mitigate methane emissions. And now I'll turn it over to Eric.
Thank you. So we've developed a unique solution that converts an environmental disaster to a valuable chemical product. By taking natural gas and flowing it through this membrane reactor you see to the right, the methane is converted into valuable chemicals like ethylene and benzene in a single step. This is what's called gas to chemicals, or has been called gas to liquids. And it's the only technology that can convert natural gas to value-added chemicals without greenhouse gas emissions. And that really is a critical benefit. If you look at the figure, I realize it's kind of complex, but when methane comes through, one of the hydrogens is removed from each of the molecules. They recombine to form hydrogen, which permeates through a membrane and is combusted or oxidized by a simple air sweep gas. That combustion reaction of hydrogen to water provides all the energy necessary for this reactor to work. So literally, there are no greenhouse gas emissions. We take natural gas and we can convert it to very valuable chemicals, billion-dollar chemicals like ethylene and benzene in a single step. The benefit of this was recognized, for example, by the American Chemical Society, where they published the article. You see the headline below: "Reactor converts methane to heavier hydrocarbons without forming CO2." And this really is a tremendous breakthrough. We've published it in numerous scientific journals, and also we have multiple patent applications as shown below, and patents as shown below. Next slide. Not only can it do that in a single step, but this process intensification and modularization can dramatically reduce the capital it costs. So rather than having multiple steps in what's called a gas to liquid process, which is shown on the right, the blue arrows, for example, of each of the individual steps, and then the various different capital equipment that are required in the lower right, we can do it in a single step, which is the circle on the left. And that dramatically reduces the capital risk and reduces the scale of the size of the reactor required to achieve this. It is the only gas to chemical technology that can economically scale down for remote site applications, which were the applications that Roger showed on the map. We've had multiple commentaries, such as the one here by Shell, where they say that the one-step methane upgrading prospect would be significant interest for any company flaring or venturing in an industrial process, and any company looking to breaking up hydrocarbons. Every chemical company has an R&D outfit that's been trying to do this for decades, and we're the first ones that have been able to do it. Next slide. Now, our first market entry is just a simple modular reactor based on reactor tubes we've already demonstrated in my lab at a reasonable scale. All we really have to do is bundle them together to have multiple tubes in a single stainless steel housing and start deploying it at these wellheads that were shown again by the map on their first slide there. The Bureau of Land Management has now regulated or is implementing regulations that will require this type of reactor on all federal lands. And they estimate this corresponds to $33 million a year in royalties for this one application alone. Again, this is of a size that we can make at our facility for Alchemedy and start deploying to various different well companies that operate these wells for their operation. But this is just the first platform technology. It has numerous other opportunities for larger scale gas to chemicals. For example, carbon-free hydrogen production or CO2 plus production. CO2 plus is the combination of ethylene and benzene and other hydrocarbons. We will partner with major chemical companies, and as mentioned, we are a Shell Game Changer Award winner because of the technology and the impact that a major chemical company like Shell has identified. In addition, we have a number of other technologies. We can produce ammonia, we can produce electric power, we can produce hydrogen, etc. All of these are further technologies. We have some slides to this in the appendix, but I'm not going to cover it here. Next slide.
This chart shows Alchemedy funding and revenue over the next 5 years. The blue bars are non-dilutive funding, orange is pre-seed and seed investment, and green and yellow are revenue. Alchemedy, as you can see from this, Alchemedy is a very early stage startup company. In 2023, $1 million pre-seed funds are targeted for standing up the company in initial facilities. 300,000 of this is from TEDCO MEIA for transitioning from University of Maryland as a facility is stood up. Not shown on this chart is revenue from a recent $4 million ARPA-E Phase 2 award. In 2024, 6 million seed funds are targeted for scaling up the facilities and staffing. First revenue is generated in 2025 with joint development agreements and initial membrane reactor sales. In 2026 to 2028, 10 million Series A funds are targeted for manufacturing scale up as Alchemedy adds other markets, as Eric has mentioned. Increased revenue in 2027 and 28 arises from continued revenue growth in the remote oil market, but then also more sales in the market in other markets such as hydrogen and liquid petroleum products. Excuse me. Next slide, please. Here you can see the Alchemedy management team. Dr. Eric Waxman is the executive director and founder. All of us have extensive leadership experience in energy R&D, product development, and business formation and operation. We are truly very excited about the business potential and global benefit of Alchemedy's breakthrough platform technology for power generation and one-step petroleum production, starting, of course, with what we've described, the conversion of flared natural gas to transportable liquid products. Thank you for your attention.
Next
Thank
slide.
you both.
Yeah.
And we have time. I did not warn the judges, but we do have time for some questions if we have some. I see that Mike has his hand up.
Good to see you again, Roger and Eric. Great presentation. So quick question for you on the use of funds from the pre-seed. So what do you guys need to have in order to prove the value, prove the prototype, prove the go-to-market in order to raise 6 million in 2024 as you projected?
We basically need to have a facility that is separate from the university where we're doing all of the development right now. We are in negotiations with the university to move into the incubator. As Roger mentioned, we did get $300,000 from the state of Maryland through TEDCO. We also got another $200K seed grant through the Maryland Energy Innovation Institute. So we're really trying to round out that $1 million to stand that facility up, to buy equipment, more on the testing side initially, because I can make the reactors in my lab at the university. But we want to be able to do larger scale testing than I would do in a university lab. So that's the first phase. The next phase is then actually growing the manufacturing side of it.
Next I have Brett's hand up, and then Michael, and then Andy.
Appreciate both the presentation. I was just curious if you've done any estimations on what the payback period for the installation of devices and what your expectation of ROI is with the byproducts being produced.
Well, it's preliminary right now. One thing I can tell you is 17 million in investment generates in what we've shown 41 million in revenue in that 5-year period, with first revenue, as I mentioned, coming in 2005. The return on investment looks like, again, this is a very general statement, but looks like 3 years.
Appreciate that. Thank you.
Michael?
Thanks for a nice presentation. My question is, so it sounds like you got some good feedback from Shell. What do you think you need to demonstrate, or what are they telling you need to demonstrate in terms of reactor size, hours, throughput, and so on, in order for a major gas producer to bite?
So the Shell Game Changer program is rather unique. They came in early stage. They looked at, our presentation, what we had done, and they gave various different milestones for their, at this stage, non-dilutive funding. And so for the first year, basically what we're trying to do is replicate what we've already done in the lab, but now do it for a longer time of testing, and also with the presence of sulfur, which is a typical contaminant in natural gas. We believe that we'll get that done without any problem. The next step would be then scaling up the reactor size in terms of the length of the tubes. But in parallel, we've already gotten the funding through the Maryland Energy Innovation Institute to now start working on the metal to ceramic brazes. So while they gave us certain milestones, we're actually going beyond that by bringing in additional funding in parallel. So what we want to be able to get to within this thing is a ceramic tube, which is basically what the membrane is. The catalyst is literally sand. It's an iron on silica, really, really cheap catalyst. But the ceramic has to be then brazed to a metal support for the feed throughs of the gases, versus what I'm doing right now in my lab, which is an O-ring ultra-torr type fitting, right? So it's multiple tubes that are basically about 9 or 10 of them that are running in parallel inside of a stainless steel housing, which we can pressurize. That's the major step forward that we need to be able to do. Shell has indicated that potential $2 million investment is available at that time, but they've given us certain things we have to do, demonstrate the milestones we have on the existing contract, get a C-suite, which we've done, and move out of the university into a real facility, which is what we're trying to get the money for.
And Andy?
I think Michael might have asked the question I was driving at here and kind of got answered, but I'll ask it maybe a sort of a follow-up on it. Have you done testing on live gases yet? And do you have any sense of what live gases is going to do to the lifetime of the reactor system?
Well, by live gases, I'm assuming you mean like, out of the ground natural gas versus a tank of methane.
Yeah, that's what I mean.
Right. We just right now done it with methane. We have identified the primary contaminant we're concerned about is sulfur. And so that is part of this year's funding through Shell, is to demonstrate the sulfur tolerance. Having said that, there are very well-known commercially viable sulfur sorbents they would just put in upstream if it's an issue. We just need to find out how much sulfur we can tolerate, and then have an upstream sulfur sorbent that will remove it down to that level. And those sorbents are removable, regenerable cartridges that would just be part of the process.
If I could add, the composition varies from field to field, even sometimes from well to well. It's likely there will be a preprocessor in there, very simple, most likely absorption based, but it will require certainly testing at each application to make sure you match up the right processing with the system.
It's
And Mr. Ravenscroft?
But
Oh, go ahead, Eric, sorry.
I was
Go
gonna
ahead.
say also for the first applications, it doesn't have to run for long periods of time. Basically, they're really drilling for oil. The natural gas comes out first, and then they want to capture that rather than flaring it, and then they can inject that liquid back into the oil. At some point, it's just producing oil, and then they can take that reactor off and move it to the next site, right? Versus we get to the large scale, you know, a giant mega or giga plant, if you want to say that, that's got to have long-term operation, but that's sort of the next level of development. That's our future market, not our first market.
Mr. Ravenscroft, I'll give you the last question on this for this team.
Thanks. Yeah, quick question. I apologize if you guys said it and I just missed it. What are the regulatory hurdles, or are there regulatory hurdles to implementing something like this? Like, are natural gas companies or oil and natural gas companies required to flare? Like, would this
Eric, I could take a little bit of this and then please feel free to add. From my experience, there's going to be ASME codes that you have to pass on the vessel. And then on the site, there has to be validation that there are no potential leakage or formation of chemicals that are serious hazardous threats. But most of this, remember, we're in an environment which has a pretty I'm not going to say nasty mix, but has a mixture already that is of questionable concentration, I suppose.
Sure. That makes
So
sense.
The existing regulations right now are just to flare. That's undesirable. And with the new EPA regulations, they will have to pay for all the gas they flare. So that's why the potential royalties, because why would they pay for something to burn when they can capture and produce something that's valuable, right? So that creates the incentive, and it becomes one of these things where it's, you know, best available technology. There are only regulations that are flaring because there is no alternative. This provides the alternative. It could become the best available technology, in which case it would be regulated to actually deploy this.
Thanks, guys.
Perfect. All righty. If we can move on to the next slides, please. We have a couple of backup slides. Okay, so now we're just real fast going to talk some about our sponsors. We would not be here without our sponsors. The first off, the Butts Foundation is a family foundation founded nearly 100 years ago with a mission to support programs that benefit humanity, education, medical research, and society as a whole. Also, sponsors are Exelon. Exelon is recognized as a industry leader with best-in-class operations, with utilities achieving top quartile or better performance in customer satisfaction, reduction of outage frequency, and fast service restoration. This record of reliability and customer satisfaction is reinforced by substantial infrastructure investments. And Constellation. Constellation is the nation's largest producer of carbon-free energy and a leading competitive retail supplier of power and energy products and services for homes and businesses across the United States. Constellation is headquartered in Baltimore with a generation fleet that powers more than 20 million homes. And not necessarily a sponsor, but one of our lead support is Points North, the small studio with big design. Points North is a design studio that helps ambitious brands transform where they are into where they want to be. They use strong design, marketing strategies, and storytelling to produce long-lasting results for their clients. And many of our MEIA clients are their clients. So thank you again. We'll be talking about some of our other sponsors a little bit further in the program. So now we're going to move on to batting in the second position is Living Canopies. And let me introduce Dean Hill, the Vice President for Business Development.
Thank you, Wade. Good afternoon, everybody. I don't know if you can hear that or not, but I'll try and talk over the raging thunderstorm that is currently on time right over my house for right now. So my name is Dean Hill. I'm the Vice President of Business Development with startup company Living Canopies, which was co-founded in 2015 by Dr. David Tilley, a professor at the University of Maryland. And what we do at Living Canopies is we fuse nature-based solutions with smart technology to create cool, sustainable, and equitable spaces for people to enjoy the outdoors. Living Canopy's first product introduction was a living umbrella, a nature-based solution to the ordinary patio umbrella. With the living umbrella, we established IP with a patent for the self-controlled solar-powered irrigation system. We successfully raised funds and we garnered sales until COVID hit. During the pandemic shutdown, Living Canopies evaluated our market position to see if the IP could be used for a larger social impact. And we also made two key trending observations. The first was that it's hot. Extreme heat events and heat waves, which kill more than 1,000 people each year, are expected to become more common, more severe, and longer lasting as our climate changes. The other observation was that mobility and technology are really having a moment. There are so many mobility options today, and a lot of it is due to the incorporation of technology. Unfortunately, our current public transportation does not reflect this influx of technology. There are 500,000 bus stops throughout the United States, but there are only 100,000 bus shelters, and that is a lot of people exposed to extreme heat. It's also an equity issue with the current transportation model, since low-income census blocks have 15.2% less tree cover and an average land surface temperature that is 3 degrees hotter than high-income blocks. The convergence of these observations is also evident in our recent discovery with mayors and other city officials that are looking for sustainable alternatives to increase access to mobility, sustainability, and equity in their jurisdictions. Next slide, please. The bigger problem is that there are very few, if any, nature-based solutions where the benefits and power of nature can be added to the solution until now. Introducing the Cool Green Shelter, where nature plus smart technology plus product equal enhanced mobility options. The Cool Green Shelters have 300 watts of solar power, 100-gallon rainwater storage, and of course, nature in the form of the green roof. The value proposition is that riders are protected from the elements and are able to safely charge devices while waiting for mobility options. The market starts with filling that demand gap of 400,000 shelters, and along with the combined TAMs of advertising and ESG marketing, Living Canopies believes that this is a market ripe for disruption. The revenue model is based on shelter sales with a 30% margin on the initial sale and multiple lines of recurring revenue after the sale, which include out-of-home advertising, ESG sponsorships, stormwater credits in Maryland and other states, and ongoing maintenance service contracts for the shelters. Here's how we scale up sales. And we need to sell approximately 112 shelters to hit the $1 million in gross sales, and that is without any recurring revenue contracts. It's also important to note that we intend to provide manufacturing jobs in Maryland and the DC area. Living Canopies has identified 4 market segments and have gained traction in 2 of the markets already. We have also formed a strategic partnership with Beep, an autonomous vehicle service provider that has a North American presence, and the Cool Green Shelters are included in their RFPs. Did I mention that we have sales? We are finalizing the sale of 10 shelters to the city of Hyattsville, Maryland, which will be deployed in the fall of 2023. The Hyattsville sale will also include a multi-year maintenance contract, and Living Canopies has active proposals with Beep, Tavistock Development, Babcock Ranch Development, and Peachtree Corners, Georgia at their Curiosity Lab. The Babcock Ranch proposal in partnership with Beep is for 4 shelters and is expected to be deployed in November. The bus shelter market is very competitive, but there are very few options that have fused nature with technology in a product offering. The Living Canopies go-to-market strategy has identified municipalities as our main market segment with the niche market of smart, sustainable cities. This niche market is well-funded and has little competition as far as nature-based solutions are concerned. We will utilize inbound and outbound content marketing as our main channel at launch, and our sales model will consist of a combination of inside sales and independent manufacturing reps that will cover larger markets. The interest in the Hyattsville deployment is already making headlines, and since the running of these 2 stories in April, Living Canopies is in direct contact with 5 additional municipalities and has been invited to present to the National Capital Region Transportation Board next week. The cool green shelters will also be featured in an upcoming segment on Tomorrow's Technology Today on WBZ News Radio in Boston, and a feature-length segment on Voice of America. Our outbound marketing will kick off this month as well, as Living Canopies will be exhibiting at the Maryland Municipal League Conference in Ocean City, and Sustainable Maryland is allowing certifying municipalities 5 additional credit points for using the cool green shelter on their projects. While we have strong traction with our Generation 1 model of the cool green shelters, Living Canopies is excited to expand its value to the neighborhood as we develop it into a node of amenities that includes multi-mobility support, internet communication and connectivity with 5G small cell, air quality monitoring, and off-grid capabilities. At Living Canopies, we like to call these green oases. And this is a concept that we have been working on with Tavistock Development here in Florida, and is based upon their vision for a community recovery zone. Our green shelters have a positive environmental and social impact. They conserve water, produce solar electricity, cool the microclimate, increase ridership, and reduce carbon emissions. With our 5-year goal of having 1,600 shelters in the market, these impacts will be significant. Quantifying and verifying this environmental data will be critical in the development of additional intellectual property. Living Canopies has assembled a diverse, experienced team, and the support staff have been very, very instrumental in the development of the product and marketing collateral. Living Canopies is asking for $1 million so that we can continue to develop IP, invest in marketing and the website, add key staff, develop internal processes for project management, and value engineer our fabrication. Thank you for your attention, and we look forward to your questions.
I see Mike. Well, let's go with Brett Clark first.
Appreciate the presentation, team. Have you had any concerns from municipalities about the maintenance of the plants themselves? I'm just curious what concerns there might be in terms of maintenance, watering, making sure they stay alive, that type of thing.
Yeah, the very first question that we ever get from a municipality is, what about maintenance? So basically what we're looking at is a multiple pronged approach. We would like to keep it in-house as much as possible, because that's really what our secret sauce is. Anybody could build the shelter, but maintaining the plants and establishing that green roof is where our expertise really lies. So we've negotiated a couple different ways. The contract that we have with Hyattsville right now, they don't do advertising on their shelters. So we're giving them an additional maintenance contract for 2 to 3 years so that we can maintain and establish that green roof. But yes, maintenance is by far the #1 question that we get in our discovery.
Mr. Ravenscroft?
Yeah, thanks for the presentation. What do you need to capture the energy? Like, is it just operating to sort of power the unit, or is the city able to capture the energy that's being generated by the panels?
It's basically just to provide the charging in the system itself. And then if we ever decide that we want to do digital display as opposed to static display, we may have to utilize that additional wattage in which to coordinate that.
Got it. What was the buying process like for your early customers?
Actually, we've gotten some great champions. I'd like to tell you, Mike, that we've had a lot of pushback on this that has really tested us, but quite honestly, everybody that we have showed this to through our discovery with MEIA says they love it. So it's really just a matter of making that product fit, that market fit more than anything else. And I think once we really have these deployments in Hyattsville in the fall, it's really just going to take off as far as awareness and what some of the capabilities are for nature-based solutions. There's this huge push right now for nature-based solutions. HUD's coming out with grant funding. The White House had a summit meeting about a month ago on nature-based solutions, and there's a really, really big push for that.
Thanks.
Mr. Campus?
Thanks for a nice presentation, and congrats on the success so far.
Thanks, Mike.
So my question is, basically, could you talk us through the ad model in a little bit more detail? I mean, you mentioned something about ESG ads, and it also shows up as a pretty major portion of the business. Should we think about this as a similar advertiser set to traditional bus shelters? Who sells the ads? Is it you or the municipality? How does that all work together?
There's a couple of different ways that can occur. Basically, what we can do is we have the if we're given the opportunity to do OOH advertising, we're working with a company called AdQuick, and basically what they do is we broker space to them. So they handle all the content, they handle all of the contract, and then basically the negotiation is if we're going to share that advertising revenue with the municipality or whether we can attain all of that advertising revenue. The concept for the ESG marketing is that there are companies out there that are really pushing an aggressive ESG agenda.
Dean, did we just lose power at your place?
At least he got through the presentation.
Yeah. Yeah, I think he got there. Were there any other? I don't know if he's going to come back or not. He did, yeah, but if you guys are okay, if he comes back on, we can ask questions at the end. If you have more
Yeah,
questions.
wait, I'm here. I can ask. This is Dave Tilley. I can answer
Okay.
any final questions. Sorry about Dean getting cut out there that way.
Yeah, if there are any other questions, Dave is the IP person. Mike, Ravens.
Yeah, I just had one quick question. Are cities buying this out of funds that they have set aside for green projects, like through either the IRA or through other like federal grants? Or are they using like dedicated? I mean, I'm just kind of curious if they're putting out RFPs for these kinds of solutions, or if this is something that they have, funds set aside for.
Yeah, I can speak, to the Hyattsville contract. I think they were tapping into some federal funds that they had access to. That's the only sale we've had to a town, but yeah, I think there's a lot of grant money that's going to be available to the towns, through the state and through the federal agencies to make these kind of purchases.
Yeah, thanks.
Any other questions?
Yeah, I've got one more.
Sure.
So, I mean, you started off the presentation this way, but you could imagine this going far beyond bus shelters, and I'd be curious to understand what else you might have in mind.
I think we're really excited about working with the Tavistock type of developers. These are huge multi-thousand acre developments in Florida. They're working on like 25,000 acre developments around Orlando and down towards Fort Myers. So there's a lot of opportunity to do these, what they call the recovery zones. So you can imagine like these neighborhoods, people out about walking around in their walkable communities, but you're in Florida, you need a place to recharge, not only yourself, to hydrate. So having atmospheric water generators there, recharging your devices, recharging your pets, just taking a break. So we think there's a lot of opportunity there, but also just with parks, where you basically need cities to have some cool space for people to take a break and relax in the rising temperatures, a place that we could provide some assistance.
Got it. Thank you.
Thanks.
Any
Like
other
Dean made it
questions?
back on.
Did Dean get back
Sorry,
on?
everybody. At least it didn't happen in the first slide.
Exactly. No. You did great. And Dave was able to answer the last
good.
couple of questions, and we can discuss those at another time.
Perfectly.
Any other
My
questions real
apologies.
fast?
Do I have any
All right.
questions?
No. I was just gonna check with the judges one last time.
Thank
Okay.
you.
Thank you, guys. Did great. Okay, we're gonna
Thank
do
you.
another quick, that's the, okay, so do another quick MEIA sponsorship highlight. And again, we wouldn't be here without our sponsors. These groups of sponsors are the ones who work with our MEIA clients on different issues that they may have. Banner Witkoff is a trusted partner in helping us protect the MEIA clients' intellectual properties. Nefos Brew is another law firm that works with us on entrepreneurial law, technology, transactions, procurement, and helping our companies set up their books or set up their legal structures. Snyder Cone is our CPAs. They help us set up the books, set up distribution tables, and those kinds of issues. And hang on here. And Whiteford, Taylor, and Preston are also another part of our legal team. They work on cost-effective business law and litigation services for our clients, especially in the innovative startup area. So those are, again, without these sponsors, we would be missing a lot of the what we bring to our clients here at MEIA. So our third presenter on deck now is Ionic Devices, and the founder is Keith Gregorczyk, and I always screw up his last name. And but anyway, but Keith, please take it away.
Well, thank you so much for the introduction. As Wade said, my name is Keith Gregorczyk. I'm an associate research scientist at the University of Maryland. And today I'm here representing our new startup company, Ionic Devices. And we're trying to do a pre-seed of 2 million. Slide. So we've all had a problem where your cell phone or laptop or your smartwatch fail because the battery expands, it breaks the case open. And an even worse scenario, the casing of the battery fails, the battery catches on fire and completely incinerates your device. And then if you advance the slide, please. And the absolute worst occasion this happens, the battery fails explosively in your pocket or on your body and causes severe lacerations, chemical and thermal burns. So our technology solves all these problems while also delivering simultaneous high energy and high power. Slide, please. So state-of-the-art lithium-ion batteries are currently made with 100-year-old techniques, which are pushed to their absolute limits. What we do is we adopt a semiconductor-based approach to make safe, solid batteries. And I'll give you more details on the process in a moment. The result of this is that batteries have simultaneous high energy and high power with a tunable cell voltage. Because we're using such advanced manufacturing techniques, we expect to produce about half the amount of CO2 for an equivalent amount of energy. And because the batteries are solid, they can operate at larger temperature windows, both hotter and colder. And finally, the method can produce batteries that have various shapes, so perfect for an already huge and rapidly developing electrical world. Slide, please. So like I said, lithium-ion batteries are currently made with very dated powder techniques that are based off of stuff developed during the Industrial Revolution. So these techniques cannot be scaled down, and they do not meet the volumetric needs of next generation consumer electronics devices. Furthermore, the liquid electrolyte used introduces safety issues as well as thermal management issues. So our technology is truly a revolution in manufacturing. We produce safe, solid batteries that leverage decades of semiconductor technology without the semiconductor price tag. So just like microelectronics industry, so if you look on the left there in sort of slide A, we're using wafers. The only difference is our wafers are made of aluminum oxide and they have billions and billions of tiny holes in it. And we need the holes to be able to get enough material to get our energy density up. So then next in B, we pattern and process the wafer just like you would do if you're making memory or capacitors or resistors, etc. And so for this example, you can kind of imagine this grid, and inside each grid, or inside each square of the grid, there's billions of 1 to 2 micron holes, and inside each one of those holes is a solid state battery that we deposit there using very standard vapor phase deposition techniques. And then so that gets us the high energy, and then the thin film gets us the high power. So next, we take that wafer, we cut it up into pieces. And so you can imagine each one of those little squares in the wafer is now an independent little battery. And at this point, they are all actual solid state batteries. They just have a low energy density or low total amount of energy per die. And what we would do is then just stack the dies up inside of a packaging. This allows us to get to a total energy, also allows us to tune the voltage based on how we wire the internal dies. And it allows us to keep the volume quite low. Slide, please. So there's a little more detail, cross-section of what we're working with. And we plan to additionally leverage capacitor packaging that's routinely used in the semiconductor industry for things like multi-layer ceramic capacitors. So inside the package, we see cross-sections of the die stacked up. So inside each of the billions of holes we see, you can see that there's a full solid state battery with the cathode, the electrolyte, and the anode. And you can get a rough idea of the dimensions that we're using here. So the stacking in the middle there is how we get to whatever energy, total amount of energy we want. And the more dies we put in the stack, the more total energy we get. And depending on how we wire them, which can be done pretty easily, and I don't show the technology here because we haven't patented it yet, but we can do this by using what are called internal MEMS pins. So there won't be an additional volume added by doing internal connections. Slide, please. So in terms of competitors, I have it here in two ways. First, I compare the state-of-the-art 18650 CAN cells. So these are the type of batteries you would see in like a Tesla. It looks like a, well, it's blurring out. It looks like a thick AA battery, and they sit at about 300 to 500 watt hours per liter. If you compare to a commercially available solid state battery from a company like ST Micro, they sit at about 20 watt hours per liter. So at UMD, we're currently making batteries in 400 watt hours per liter, and we expect to be able to get to 800 watt hours per liter with ionic devices in the next 24 months. And we can definitely get higher than that by swapping out cathodes, but we can get into the details about that at the end. Slide, please. We've been working on this problem for 14 years, and there's been a total of about 30 million in non-dilutive federal investment. So the project originally began about in 2009, and it was just aimed at understanding the fundamentals between nanostructured materials and electrochemistry. And then now we are working on arrays of full solid state systems, and with your guys' help, we're going to commercialize all this. Slide, please. So we've done some initial consumer discovery through the MEIA program. And the area we've landed on is consumer electronics, but particularly the Internet of Things, or IoT. So just to define that, IoT is generally non-standard computing devices. They connect wirelessly to a network, and they have the ability to receive and transmit data. So on the industrial side, you can basically think of distributed sensor arrays for applications like monitoring green energy production, in traffic spaces to keep track of bridge stability, road conditions, things like that. In the manufacturing space, you can imagine having sensors on large inventory spaces and being able to rapidly know what you have and where it is. And then in agriculture, this is very similar, where you can measure nutrients and moisture levels, for example, in a field, or know your tractor in principle could be an IoT device, because you could check on your phone what the fuel levels are. And then on the consumer side, this is stuff we work with or have around us more often. This is in many sense your cell phone, your smartwatches, your Fitbits, everything that you're wearing or is in your house, and it's keeping track of things you do. And so we've begun talking with all these companies like Whoop and Medtronic, Wiliot, Boston Scientific. We had a great conversation with Garmin about a week ago, and we're meeting with Black & Decker soon. Slide, please. So all that data we've sort of coalesced into this opportunity attracted this map, and so you can see here that we plan to go for the consumer industrial IoT space. This is about an $8.5 billion industry currently, and it's expected to grow about 17% by 2030. So a large space of growth there still. It's important to note that we would also be quite disruptive in implantable medical devices. However, these devices require up to 7 years of approval by the FDA, so it's not really a great space for a startup company to pursue. But everything we learn in the industrial and commercial IoT space will be automatically applicable to them, and I think we would have some traction in a few years in that space as well. Slide, please. So our business model is largely based on the way batteries are currently distributed. And the way that works now is that the batteries are sold to a distributor, and then the manufacturer will request them from the distributor to meet its customer's demand. So the way we would have to approach that is to talk to end customers to get the desired specs that they want, and then try to help get some pull from them through the distributors. Though I think it's important to note that with the Biden administration's push to reshore manufacturing and supply chains, this might change, and we might actually have a direct route from us to an end consumer who's some electronics manufacturing corporation. Slide, please. So we're asking $2 million in pre-seed, and we've tried to break the phases up to best deal with the risk associated with developing a new manufacturing process. So the pre-seed phase, we address the manufacturing risk by contracting with foundries to do the initial sample fabrication. We already have a good working and personal relationship with both Forge Nano and Vigo ALD, and the companies are both quite excited to work with us. This is a dual advantage of quickly producing a set of samples to validate the manufacturing process while also allowing us to evaluate the equipment that we eventually want to buy or start buying in phase 2. And then once we do that in phase 2, the goal is to try to get to test kits so that we can get them to customer hands. And phase 3 would be raising a Series A off the test kits. Slide, please. We have a great team lined up to do this. Myself, I'm an associate research scientist at the University of Maryland. Like I said, my expertise lies in the intersections of solid state electrochemistry, energy storage, and semiconductor manufacturing. We have Joel Blanco, who's on the call right now. He's currently working at Intel, and he's our business advisor. Dr. Nam Kim has been leading the sample production at UMD, and then Professors Gary and Sangbak Lee have been working on these on this problems for 20 and 30 years or 50 years combined, depending on how you want to look at it, and are essential to the scientific background and success of the company. Slide, please. So thank you so much for your time and for this opportunity. I really appreciate it. And if you have any questions, I'm happy to answer them. And I leave you with a more detailed Ragone plot if anyone knows what that is and wants to talk about it. Questions?
Questions from our judges? Mr. Campus.
Yeah, so thank you for a nice presentation. Super interesting.
Thank you.
The first thing I would want to understand a little bit better is, on what basis is the 800 watt-hour per liter measurement done? Is that on at the cell level, at the die level, at the
That's a great
package
question.
level?
It would be the
And
die.
conceptually, like, help me understand how you hit such a high energy density versus, these hugely scaled up systems.
Yeah, that's a great question. I can answer in two ways. So first, the high energy density literally comes from taking advantage of nanostructuring. If you jump back to, I don't know if you want to do that, but if you look back at slide 5, it has a loose picture of it. But what we do is we put all of, we use vapor phase or electrochemical deposition to make our cathodes quite thin. They're on the order of 300 nanometers. Our electrolytes about 100 nanometers. Just physically, there's it doesn't that the electrodes are very close together. That gets you the high power. And then the high energy just comes from by taking advantage of the massive amount of surface area we're doing to increase, or we're increasing by using these porous wafers.
Brett, I have you next on my screen.
Appreciate that. Hey Keith, just be curious in terms of you talked about the levels you're currently seeing in the lab around, I think you said 400 watt hours per liter.
Yep.
Just understanding what are the what iterations and what needs to occur to make that jump to the larger energy densities.
Yeah, great question. So right now we're building everything on top of a silicon wafer. So it's that porous aluminum oxide I discussed, but it's merged onto silicon. The weight of the silicon takes away a lot of the energy density. Plus, the way we're doing it, we can't actually get to very high aspect ratios when it's on a wafer. When the AO, when the wafer is just AO and the holes are much bigger, we can put more things into it. So basically, it's just making bigger holes and putting more things into it to simplify it. And so right now, our holes are very small. They're about 100 nanometers, or sorry, about 400 nanometers. Our cathodes are about 100. That gets us the very low 400 watt hours per liter. By doubling just the thickness, or by increasing the thickness of the cathode, which is equivalent of making the holes bigger, you jump that up to 800 watt hours per liter. And then we can go higher than that by swapping out to better cathodes.
And are these not the new specs of those? Is that feasible with when you're moving over to the forge in terms of their current manufacturing methods? Do you see some compatibility there?
Yep, definitely. So that's one of the reasons. So they have the sort of semi-annoying split is they have developed a lot of the materials we need through our help, my personal help as an academic. I've consulted with them, so I'm quite familiar with what their capabilities are. And then yeah, so then from the manufacturer, like the equipment perspective, Vico has like the perfect tool that we want from them. And so we got to try to figure out how to balance the material and the tool, but I don't know, I'm friends with all these people. I'm not too worried about it. But yeah, and then, like I said, if we just swap out the cathode here is lithium vanadium oxide. It's a 2-volt cathode. If we jumped it up to a 4-volt cathode, you immediately double the energy density. And I want to just make a point to say that these calculations include the weight of the AAO and the top and bottom electrical contacts. So we're not averaging out the weight or the volume of the substrate. We're including it explicitly here. And so the only thing I'm not including is the packaging. So if every percent volume packaging we do add, we'll take that percent volume away from the total energy density. But like I said, we have some innovations here that are currently unpatented, so I haven't shown them, that will allow us, I believe, to patent, to wire without having to add external wires.
Andy, I see your hands up.
Yeah, sorry if I missed it, but did you have a comparison on the dollars per watt hour or dollars per watt relative?
I do. It's if you skip forward 2 slides, there's the back. I have a backup slide on it. I can go through it.
Uh-oh.
I wrote it. While they get it back, so yeah, we spec'd it basically to a one more. It should be, yeah, slide 70 then. Perfect. Okay, so we kind of, this is the back of the envelope. So we spec'd it to an LCD screen, and the reason we chose that is because it's basically the same number of steps with very similar equipment and tools. So back of the envelope, you know, a 12.5 by 20-inch monitor turns out to be about, let's say, 0.68 cents per centimeter squared. Let's assume 50% of that is commercial markup. And then we take that number, 0.34 cents per centimeter squared. We can argue about the validity of that specific number, and we'll use that to pull out the costs based on our wafer diameter and our modeling and the surface area. So what we were ending up with was it right here. So the short point is that with the chemistries as we have them now, we are at parity with sort of lower grade lithium polymer batteries. As you can see on the bottom of the table there, there's some numbers that represent the size of the battery. Don't worry about that. But you can see the cost per milliamp hour is basically at parity. And then if you compare to higher end batteries like Apple, the ones that Apple uses, we're almost over a magnitude cheaper. So that's also great. Again, this is back the envelope. It doesn't include, you know, amortization of equipment and, you know, stuff like that. But as long as, you know, more or less, I think that it captures the gist of it.
Mike, if you want to go ahead, Mike Ravenscroft.
Sure. Nice to meet you, Keith. What does the patent portfolio look like at this point?
We have, so the University of Maryland, we're negotiating currently with them. There's 3 patents that we have as academics, and well, Maryland owns them, but we're working on getting them to the company. And we're very well covered. This is so out in the weeds compared to the way normal battery people make batteries that there's nothing that, you know, we're pretty well covered. And I'm expecting that we will develop more. My pandemic project was essentially writing the patent that the company is now based on.
And you said 30 million has gone into funding.
Yeah, so
presumably the research, right? I mean, it's
those are
all directly related to these patents.
They're all directly related. They all funded the patents, yes. But there was other research being funded by those same programs that wasn't explicitly this.
Any other questions? We have time. Any other questions?
I just had one more. Keith, you mentioned one of the first couple of slides about the carbon benefit.
Yeah.
Could you just talk a little bit more about that? Yeah,
it's so the way batteries are made currently, there's a lot of very old, expensive steps like ball milling, sintering. There's tons of expensive annealing steps. And so every time you got to heat a furnace up to some absurd temperature, 1000 degrees C, to get the copper phase formation, you're burning tons of carbon no matter what you do. And this typically happens, these batteries are made in China where there's no little pollution controls. And that, you know, it's very pollution intensive to make a lithium ion battery. By switching to semiconductor manufacturing, we're dropping all the temperatures out. We're removing all of these, you know, dated techniques. So there's no more ball milling or sintering or all this high temperature stuff. We are using temperatures, but like 300 degrees C instead of 1000 degrees C. And so that's one piece of it. And the other piece is the overall time from sort of precursors to product is insanely shorter. So in the regular battery world now, it's about a month. You get a bunch of powders in about a month before you'd have a working battery. I can't quite predict, but it should be on the order of, a day or two. What we're doing, semiconductor processing is significantly faster. You should have, I expect, a packaged battery in less than a week. And maybe even faster. We don't know yet.
Okay. Well, we got them. Any other questions? Mr. Campus?
You've talked about consumer electronics and IoT as a market. What other markets do you foresee for this? I mean, is there a path for this technology to make its way into larger format batteries?
I think so, yes. It will work. It's all about developing the larger wafers. It basically follows a very similar trajectory as the current semiconductor world did to produce larger and larger LCD screens, right? So the past few years, we've seen them up to a couple 100 inches or some insane level. And so we would have to follow basically that same path, developing larger and larger substrates that we could use to make larger and larger batteries. There's nothing in principle preventing it from happening. It just hasn't happened. So there is the possibility of getting to large format batteries like grid and transportation, but that would be a long-term process. And I think there's a much larger, more immediate, faster market in the micro battery world.
Okay. Well, we'll thank you guys very much. Keith, wonderful job.
Thank you so
And
much.
we're going to move on to some of our other sponsors spotlights. So MEIA is funded by a grant from the U.S. Economic Development Administration within the Department of Commerce. Brian Toll and Ben Margolis took their idea and were able to secure a build to scale grant. And that is the beginning part of MEIA, which is then matched with funding from the state of Maryland, but we wouldn't be here without the EDA. The Johns Hopkins Ralph O'Connor Sustainable Energy Institute is a new institute at Johns Hopkins as they move into clean tech and into energy tech. They wanted to rival how Johns Hopkins is known, in the bio and medical world. The Maryland Energy Innovation Institute, which Dr. Waxman is the leader of, between what's called, the Ralph O'Connor Sustainable Energy Institute is also known as ROSI, and the Maryland Energy Innovation Institute is MEI2, or MEI squared. Those two really are the leaders in providing these companies that work with MEIA and get us to where we are today. And both programs are wonderful, and we would not have these presentations without either of those two organizations. And then finally, the Maryland Clean Energy Center. It is like the Green Bank for the state of Maryland, and they are my parent company. MEIA is a program within the Maryland Clean Energy Center. And again, on October 17th, they're going to be having a clean energy summit. Please mark your calendars and we will get you invites. It's going to be a wonderful day, but again, that's October 17th. And now we're going to go to our cleanup hitter. Let me wait until we make sure that we got it up on the screen, which is Brightwave. And let me introduce the co-founder and partner, Mr. Tim Shaw. Take it away.
Hey, thanks, Wade. And hey, before I get started, I just wanted to say thanks too, because over the last year, you guys at MEIA have been crucial to our development. Just the support's been fantastic, and we've gotten some really good introductions out of you guys too. So we really appreciate that.
Thank you.
All right, so to get started, good afternoon, everybody. My name's Tim Shaw, and my partner Ken and I started Brightwave to fight what we thought was a challenge for an entire industry. So we have developed and patented advanced photobioreactors for growing algae. And they're about 300 times more effective than the prevailing technology, and they cost less. So we're going to change. We're basically disrupted to the way algae is grown today and the way that algae biomass is used across a large number of industries. Slide. So algae is unique. It is a versatile, optimal, renewable feedstock for a lot of industries. It's used for everything from, fighting food shortages to developing biofuels and bioplastics. The problem is that the industry today is completely broken. It's worth about $15 billion, and that's in spite of itself because of the demand for algae and biomass. But the industry, it does not optimize yields. It does not control for contamination. And the big sticking point has got unsustainable land requirements. Slide. So we did it, Brightwave is we developed an algae cultivation platform that addresses each of those challenges. We provide consistent high volumes, we provide lab quality biomass, and we do it at a lower price than anybody else out there. Next slide. So the specifics. So again, we've developed this photobioreactor. A couple of the key features. One is that it's internally illuminated. So Ken and I invented an in-water grow light that goes down into the culture inside of this bioreactor. So before Brightwave, if you wanted to cultivate algae or grow algae in a bioreactor indoors, you had to light these things externally. You had lights on the outside of the tanks, and that light had to try to fight through the material of the tank and then fight through the density of an algae culture. So it limited the size of these tanks to no more than maybe 18 inches across. Because we can put lights inside of them, multiple lights, we can expand these things vertically, horizontally, to whatever size the customer needs. The second feature is that those in-water grow lights are self-cleaning. So typically, if you were growing algae or any water-based crop, you're going to have biofouling on surfaces between the plant, the organism, and the light source. So if you're lighting these tanks from the outside, you get algae that biofouls the tank surface. We do away with that. So what we do is inside one of our bioreactors, every liter of culture is getting the same amount of light, and every liter of culture is getting the same amount of light, whether you're day 1 or day 30 into a growing session. And that's something nobody else can do. The internal illumination also helps us maximize footprint efficiency. So one of the key metrics for growing in agriculture, whether you're talking about water-based crops or terrestrial crops, is aerial productivity. So the number that everybody chases on either side of that fence is 25 grams per square meter per day. We're at about 144 grams per square meter per day, about 6 times that standard. So what does that mean in terms of comparison? If you want to compare what we're doing to a typical algae grower, one of our large bioreactors, it's about 12 feet in diameter. It's the size of a bedroom. Will produce as much biomass as a 1-acre algae pond. Compare that to what terrestrial crops are doing. That same bioreactor, about the size of a bedroom, will produce as much protein as 2 acres of soybeans. Next. So one of our initial customers is Minus Materials. They are a carbon negative cement manufacturer. And, one of the key components of Portland cement is limestone. It's mined and then it's burned at high temperatures. Both of those activities generate a lot of CO2. Minus Materials developed an extraction process for algae where they create biogenic limestone from algae. So that process reduces CO2 emissions from cement production by about 60%. Before we got involved with them, these guys were planning to grow all their algae in regenerative quarries outdoors. It was going to take up a massive amount of land and it was going to be located in remote locations. We provided them with one of our bioreactors, and within 2 weeks, in fact, they were out of the Indy Bio Accelerator in San Francisco. We became the linchpin of their technology. And that's because our bioreactors can provide high volumes. They practically reduce the risk of contamination to 0. And the key thing is that footprint efficiency. So instead of having to grow algae out in the middle of nowhere and truck it to sites, they can co-locate it with manufacturing. And in fact, they're getting ready to do a pilot project with Cemex out in California, or Colorado rather, and they're going to use one of our bioreactors right on the Cemex site. And this is just the tip of the iceberg. Next slide. So we have a very large market that we're going to dip into. That $110 million represents where we think we're going to be in about 6 years. And that is based on converting, that number of customers you see right there from those industries. It's not a far stretch from where we are right now. Next slide. So how are we going to get there? So we take the industries that we want to penetrate and we've separated them into 2 segments. The first segments are the growers. Now, these are those industries, so it's food and beverage, animal nutrition, and aquaculture. They're already using algae. They already know how to use photobioreactors. Our PBRs are a turnkey sale for this market. Well, on the other side of the fence, we have feedstock consumers. Most of these prospects and customers are decarbonizing. And then you have industries like pharmaceuticals that are there to take advantage of a lot of the bioactive compounds present in algae. So it truly is a versatile feedstock with a toehold in each of these industries. The cool thing is, as much as we've sought to focus on those first three target markets, we are getting hit with opportunities from a lot of the other industries, and we think that reflects a lot of latent demand out there, and we'll come back to that slide. So we do foresee a pretty fast revenue growth over the next 5 or 6 years. We're going to sell larger tanks as we get into this. We're going to sell larger systems of tanks as we get into this, and we're going to see our service revenues increase, both because we're doing the installation and maintenance work for a lot of these folks. And then we're already getting asked by a lot of prospects, not just to sell them tanks, but to take on the work of growing the algae for them. Next slide. Competitively, our primary competitor on the photobioreactor side is industrial plankton. There are a lot of companies out there that produce bioreactors, but the vast majority of them are pilot and bench scale. They're very small. Industrial plankton's largest PBR, or photobioreactor, is 1,250 liters, which is going to wind up being one of our smaller ones. So that 1,250 liter PBR, theirs takes up 55 square feet of floor space. Ours takes up 9. Theirs weighs about 4 times as much as ours. And the price of theirs, that 1,250, is about $81,000 compared to ours, which is about $25,000. So we've got a lot of room to grow there. Oh, next slide. The team is Ken Peretti and myself. We started Brightwave 3 years ago. We've been doing this full time since. Ken and I have been working together on algae products and with startups for about the last 8 years. One of our key advisors is Mark Allen, who is really kind of the father of commercializing algae and algae biomass. And then we're getting ready to bring on a really good marketing person in the next couple of weeks. Slide. We do believe that we're a lower risk investment. We are bringing a disruptive technology to the market. It is first in the market, first in the world. We have secured a U.S. utility patent for it. We secured that last year, and we have filed for patent protection in some key international markets. You see those there. We do have a strong management team. I think where Ken and I really shine is we know what we don't know. So we have formed some really solid partnerships and relationships, especially like on the science side of the house. And then we feel like we've got increasing momentum in the market as well. Next slide. So we have 3 customers currently in hand, and over the next 6 months, they're going to produce probably around $200,000 for us. But I wanted to just highlight the traction we're seeing in some of the markets outside those core markets we've targeted. So cement, I mentioned, we're in discussions with 5 different biocement, and they're actually not biocement companies. They're cement companies that are implementing biosolutions. Maryland, for example, is going to require companies in 2 years to have organic components to its cement. So we're getting ahead of a lot of those regulations, and we're actually going to do a pilot with one of the international companies here before the end of the year. Sustainable aviation fuel. We started working with a sustainable aviation fuel producer about 2 months ago. They had developed their platform back in 2007 around algae as a feedstock. But about 10 years ago, algae could not meet the demands that they had, and they turned away towards other feedstocks. We're giving them a reason to come back to it, and we're going to do a pilot with them. And then finally, we are doing some work with the Maryland Environmental Service. They run about 170 wastewater treatment plants in the region. We are actually going to take over one of the ones that is non-compliant. We're going to plug one of our bioreactors in as a tertiary treatment. We're going to take clarified water, just run that water through the bioreactor, remove the excess nitrogen, and then release the water. So they're going to have clean water out of it, and they'll have the nitrogen credits that they can trade as well. And that is, oh, I'm sorry, one more slide. We're opening up a $600,000 seed round, and that money is going to go primarily towards standing up our marketing and sales resources and tools, because we really want to expand in that area. But the key requirement for us is to wrap up our fit and finish on the design of the tank. While it does everything we say it does from a performance standpoint, we still think it looks like a prototype. And we have a relationship in principle with Harbor Designs in Baltimore just to do the fit and finish, and then we get this thing over to contract manufacturers. So that's us in a nutshell. Thank you.
Thank you. To our judges, Andy, I see your hand first.
Yeah, can you elaborate a little bit more on sort of what makes up the core IP here? Like what is the innovation making up the core IP that's been patented?
Actually, you're kind of looking at it right there. So there are two key claims in our IP. One is the in-water grow light. Lighting these things from within. Nobody else has ever done that. We did some extensive brownfield searches prior to filing the patent application, and people had made a go of it with some really kind of odd ways of getting about it. But we are the first ones to develop those. We've removed the heat from those things completely, which is the key piece of that. The second piece of our IP is the scrubber for the lights. It's a ring scrubber that moves up and down those fixtures and keeps them clean from biofouling. You know, and it depends on what kind of algae is being cultivated. Some customers might run those things a couple times a day. Some customers, you know, growing a lighter algae may only run them once a week or once a month. It really depends. But that's two core claims of our IP.
Other questions? Mr. Campbell.
Hi, Mike.
You mentioned sustainable aviation fuels as one of the applications down the line, and I'd be curious to understand when do you think that could be addressable, and you know, at what level of performance for the system do you need to get there?
So the requirement we have on us now is to identify a strain of algae that is high fat and lipid content as possible. We've done that. We're going to run a pilot here in the next couple of months with one of our 1250 liter PBRs just to test the throughput and make sure that what's coming out measures up to their requirements. But after that, we're ready to run. They want to do a 50 million gallon per year pilot from there. So we're going to attempt to grow this pretty quickly.
Mr. Clark.
Thanks for the presentation, Tim. Can you just talk a little bit more about the sales cycle in terms of what kind of validation is needed from the potential customers and just what that looks like?
So we are delivering a PBR to a medical customer next week. Actually, they do bioluminescent dyes for medical treatments. We are delivering a PBR to them that they're going to trial for 30 days. And then if it works, they're going to buy another 15. So I think as we're starting out as a company, you know, we're going to be doing some small pilots, but it's going to them with the understanding that, hey, if this works and we identify what the timeline looks like, you're going to buy this many coming out of it. And we expect to see a lot more of that.
We have time. Any other questions? All right. Well, Tim, thank you so much.
Thank you all. Appreciate it.
All right. Well, the judges need to escape off to their, they have a place to go to evaluate and come up with a decision for, you know, to select a winner. And we greatly appreciate it. And but during that time, we are going to do some, we're excited to have some team updates. Again, these are former MEIA clients who have gone on doing great things. And we wanted to take some time and let them present how things are going. First up is Ryan Powell with Monte Biofuels. Ryan, the floor is yours.
Hi, and Wade, I've got a very short presentation, so we'll see if I can share the screen. Let's see here. All right. So I can just give you looks like I can't share. I don't know if you guys can enable that, or I can just go on and just talk.
We'll see. You're beyond my technology abilities. So I don't know if Sabrina or if they can give us the high sign or the no sign.
I stopped sharing, so you should be able to now.
All right, let me give it a shot. All right. Can everyone see this?
It's starting to come. There, it's there now.
All right. Well, thanks, Wade, and thanks, Mike, for having me back. Certainly, Accelerator was very helpful for us. Our company is Manta Biofuel. We have been around for a little while, and our general history is that we started as a biofuel company where we grow algae, harvest it, and convert it to renewable crude oil. And so we developed, this is the opposite end of the spectrum from the last presentation, growing algae outdoors at very low cost. We developed a patented magnetic harvesting technology to provide really low harvesting cost and a method to actually convert the algae to renewable crude oil. So since then, we've decided to focus on just that core harvesting technology that we developed, and we're using it in actually the water treatment space, where we've converted this to essentially a mobile treatment system where we can remove lots of different contaminants, coarse algae, but also other suspended solids and phosphorus. And the one advantage of this technology is that it has a very small footprint, and as you can see in the picture, it does a really good job of removing algae. So we've done quite a few different pilots. We've been able to pull some revenue in for this, and we've got quite a bit more in the pipeline. We recently did a pilot with the Maryland Port Administration at their dredge material containment facility. And we have a quote in right now with them, so we should be hearing back any day. But essentially there, they have a problem with algae in this big facility, and they have to discharge the water, but they can't actually discharge it because it doesn't meet permit limits. And so that's where our system comes in, and we're able to get the water quite clear and well within their permit limits. And so we're working on moving on to the next phase in that project. And one other thing Mike asked me to talk about was our crowdfunding that we've done. So there's a lot of ways to raise money for a startup company. So far, we're at about $5 million that we've raised so far. But one place I think that's actually pretty helpful for clean tech companies is crowdfunding, where you have a message that can resonate with the audience that's out there. And so we did about just under $2 million round on Republic, and we're currently doing a round on Start Engine right now. And so I think it's an excellent way to raise funding for clean tech companies. There's definitely advantages and disadvantages. So I thought I'd leave anytime if anyone had any questions. Also happy to talk about doing crowdfunding offline if anyone's interested. And that's what I have.
Ryan, thank you so much. Hey, Ryan, I do have one question for you, and this is more of a personal question. We worked together on the, you guys did some stuff with the COVID manufacturing grant.
Yep.
Did you guys not?
Yeah, we did.
I was trying to remember where I met you, but I greatly appreciate. I was lucky enough to work on that project when I was with the Maryland Department of Commerce, and we greatly appreciate all the companies that helped out with COVID relief. So, but thank you very much for helping us with that.
Yeah, that was certainly interesting times. We shifted from biofuels to making face shields. And I mean, for our team, making face shields was quite a bit easier. And we scaled up manufacturing to, I think we were high hundreds, low thousands per day at one point making face shields. And then we were able to sell those off. So that was certainly interesting times.
Yeah.
And
it was. No. But thank you so much. We had many Maryland companies that did that, and we were able to increase our PPE supply, and it was great fun. Our next, if you can unshare your screen real fast.
Yep. Let me see if I can stop sharing. Yep.
Perfect. If we can go back, or our next is actually the winner last year of the MEIA pitch competition finale, EDAC Labs. We have James Levine with us. You're on mute, James.
Thank you, and it's been a pleasure watching all of the presentations. So I actually don't have PowerPoints, which will probably be a relief to all of you. But I want to take a few minutes to both update you and, sorry about the jets flying by, and give you some kind of color around some of the challenges that probably aren't unique to us. First of all, though, I do want to thank MEIA and what it put together. You know, we used Nephros Brow for our legal counsel and we continue to use them. We use Banner Whitcoff to review some of our IP. Our logo came from True North. And the most important thing I got from you was Brian Toll. And Brian sat down for MEIA to join me as co-founder of EDAC Labs, and that has been of inestimable value, as I'm sure you know. So where are we right now? And then I'll go back through kind of the last year. First of all, for you who don't know what we're doing, this is technology out of Hopkins, out of the Wang Lab at Hopkins, and it sounds incredibly boring. It's electrochemical creation of acid and base from salts. So for example, from table salt, you can make NaOH, which is caustic soda, and you can make hydrochloric acid. Sounds pretty boring. You can also start with sodium sulfate and you make sulfuric acid. Well, there's 340 million tons of sulfuric acid being used in the world and NaOH. The original focus of the company, the original tagline was, you know, gigaton scale direct air capture. And I think over this last year that shifted to now acid-based electrosynthesis for carbon capture and mineral extraction. Because one of the key developments over this year is the Wang Lab got a $2 million grant from ARPA-E for applying it to the miner program to try to provide innovative ways to extract more minerals. Acids and bases are used extensively in the mining industry, and we believe we will ultimately be able to provide critical acids and bases, particularly sulfuric acid, to the mining industry that will result in both carbon capture, enabling carbon negative mining, reduced nastiness, shall we say, in the mine tailings, because they'll be stabilized as mineral carbonates, and because we recycle the sulfur, greatly reduce sulfuric acid getting out into the environment. So we think we can do that all at a price comparable or below. But some of the sort of stuff that's happened, you know, we formed the company just after the competition, just about a year ago. We injected some formation funds from Brian and myself, and then we started license negotiations with the university. That turned out to be a 10-month process of trying to get license negotiations. And I comment to all of you that are starting stuff out of universities that I think there's still a disconnect with regard to clean tech expectations or changes between, say, bio and some of the semiconductor IP royalty expectations and expectations of what's available in clean tech. Where to make a difference, you're dealing with things that are $100 or $200 or $300 a ton. And there are no high margin industries in that. So I just comment that can take a lot longer than you expect. And I think there's an adjustment that's been reflected in discussions I've had globally on that topic at sort of every university in the United States. So then we started, we did our license negotiations. The lab has been going full speed. Technological development's been going great. We started fundraising in late fall. We actually got, we also raised a few $100,000 in whatever you want to call it, pre-seed funds from long-term investors of mine. And other kind of comment, of course, is you really want those early stage investors to be people that understand risks, have some real relationship with you, and kind of have been around the block in terms of early stage investing. Unfortunately, I've been doing this for 30 years, and that was not a constraint. We actually secured approval at a board level from a major climate investor back in February, but we still didn't have our license done. So we finally got the license done a couple of weeks ago. And that should close next week on our funding, and then we'll round it up with some existing investors we have, where we're still open probably for about $300,000 to bring it up to $3 million, which is all we think we need at this point. The other major comment I'd make from having operated in multiple startups around this country and also overseas, and that's Maryland has a tremendous lack of spaces for what I call real tech stuff. They're really quite dramatic. I've personally been involved in about 2,000 lease negotiations, and I don't think I've seen a more difficult market for making real stuff. However, I would say we think we're starting negotiations on a space in a park that has some more space, has a lot of good features in it. And if we start to wrap those up and anybody's looking for space with high ceilings in a reasonable industrial park within fairly close proximity to the Baltimore area, maybe it'll give them some help and advice because they already expressed an interest in more sort of tech startups that want to do real things. But it is an interesting problem, particularly a problem, I think, in anything that requires something that might slip into heavy manufacturing, which some of these processes do. So we're actually ready to rock and roll. We can get some space, finally drag this stuff out of the lab, even though that's been doing great, get to scale up. And because what we're doing is so what I call fundamental, I'm less worried about some of the customer stuff than some other people are. I just want to get our technology scaled. And then I'm not worried. We'll find our markets. So
Absolutely.
thank you for the help me and all those things. Yeah.
Yeah. And James, as Brian says, we're not a cheap date when it goes to looking for office space. We need everything.
Yeah. And and by the way, this cheap date is, it's not even an expense issue. There's just literally, it's such a focus on the bio stuff that there's a paucity of things needed to make the energy transition happen.
Absolutely. Well, we greatly appreciate you providing the update today, and you stole Brian fair and square.
Yeah. Yes, and I'm very glad I got him. Yeah.
Absolutely. Well, we actually we do have a winner, and so I am going to hand it back to Patrick Wynn with the Maryland Department of Commerce.
Thanks, Wade. I appreciate it. Once again, congratulations to all the presenters. I'm sure that the judging panel had a difficult time in their selection of the pitch competition winner. However, there is a winner, and I'd like to congratulate Alchemity as the winner of the 2023 Climate Tech Pitch Competition.
Perfect.
Congratulations.
Congratulations. Congratulations to all and
very
for
much.
everybody who pitched today.
Thank you so much.
All righty. Well, thank you. And Roger, again, Roger, Eric, thank you guys so much. Thanks for everybody who participated. Yeah. And to everybody who participated, our sponsors, we wouldn't be here without them, and our team. Again, that is Brian Toll's photo right there. Again, he was with Ben, the brains behind MEIA, and I'm glad to where we brought it. But to Mike, Emily, Mary, Rylan, and Sabrina, they were behind the scenes, and everybody. All I can say is they're just good people, and they've been a huge help, and they made me look good and help support our teams. But that's all I can say. They're just good people. Just to give you some ideas of where, and then again, to thank all of our sponsors, all the people who support MEIA, make us what we are. I just wanted to give you some ideas. We're going to be doing a pitch competition. I don't know about a competition, but we're going to be doing a pitch event in the future. But to give you some ideas on coming attractions, we have some exciting MEIA client or customers coming along. One is using DC power to run appliances, which mean you can use solar off grid to run refrigerators, air conditioners. And then we also have a company out of Frostburg that is working on filtration. They thought they were going to be in the pet market, but it turns out there's opportunities for them. Pre-filtering water at power plants, both pre and post, before the water goes into the boilers. And also with they have opportunities with aquaculture. We're bringing on a new company from Johns Hopkins that is recycling plastics using catalysts to break plastics back down to their original forms, and then hopefully be able to use those again. And then we have two companies that are working on insulation. One is focused on glass. The other is focused on concrete or materials, insulation, fire resistant, but high insulation materials inside of buildings. All of those are going to, just like the four companies you saw today, they are all going to take a small bite out of the problem to solve our climate needs. And so please, if you need our email addresses, how to locate us, how to get copies of the presentations, how to find our companies, please write down the email addresses, take a quick photo. But everybody, thank you all so much. And we look forward to working with everybody in the future. And again, that's all I can say. It's a great day and it's very exciting. Thank you all.
Thank you.